Welcome to this video demonstration showcasing EMC infrastructure for high-performance Microsoft and Oracle database systems. This demo highlights the capability of EMC technologies such as VFCache, Symmetrix VMAX 40K, FastVP, VMware vSphere 5 to support the virtual infrastructure of the mission-critical enterprise applications. We will first talk about the architecture design of the demo environment. Next, the test results of VFCache acceleration to applications will be discussed. VFCache clustering support demo will be shown after that. We will summarize the solution at the end. Architecture design. This solution is built on EMC Symmetrix VMAX 40K arrays with FastVP continuously relocating data across storage tiers based on access patterns and predefined fast policies to tune the performance. EMC VFCache provides the host-side performance acceleration for the OLTP applications. 2 OLTP and 1 DSS Microsoft SQL Server 2012 databases and 1 Oracle 11G R2 OLTP database and a Microsoft SQL Server Failover cluster are provisioned in a VMware vSphere 5 environment. Load generation tools simultaneously drove all application loads to validate the infrastructure and acceleration function from VFCache. Failover was performed for the SQL Server Failover cluster to verify the integration of VFCache and Windows Server Failover clustering. The VMAX front-end port groups are designed to separate the I/O by its size. OLTP application is typically 8 to 64K I/O. DSS has large I/O size ranging from 8K to 256K. Oracle and the SQL Server OLTP database VMs are on separate ESXi hosts. They share 8 FE ports on the VMAX. DSS and the SQL Server OLTP database VMs are on the same ESXi host. Their FE ports on the VMAX are separated. The application workloads were logically separated using masking views within the VMAX 40K and HBAs. In this environment, the FastVP policy is set to use 100% for each of the included tiers for the OLTP applications, and only FC and SATA tier are included in the FastVP policy for the DSS application. All log devices and the temp files are pinned to the FC tier. Test results. In this 3-tier FastVP configuration, the IOPS at VMAX 40K front-end adapter reduced from 40,000 to 12,000. About 28,000 IOPS was offloaded by VFCache. VFCache significantly reduced OLTP database response time, the storage array IOPS, and backend adapter utilization, with no impact on OLTP TPS performance. The array was freed up for additional I/O requests. In the 2-tiered storage configuration, before enabling VFCache, disk utilization almost reached 100%. The storage as configured reached maximum IOPS around 10,000. The application response time also suffered. SQL Server OLTP had average disk response time more than 20 milliseconds. Oracle had the response time more than 35 milliseconds. After enabling VFCache, the FC disk utilization was dropped to around 65%. The maximum IOPS is about 3,000. The application response time was improved dramatically. Both SQL Server and Oracle OLTP response time was dropped to no more than 3 milliseconds. VFCache cluster support. First, create the VFCache resource in the SQL Server instance. Choose Add Resource, generic script. You can find the VP script named VFCache State Control in VFCache installation directory under Microsoft_cluster service subdirectory. Bring this resource online. Set the VFCache resource dependency to the accelerated shared resource length. Set the SQL Server service dependency on the VFCache resource. Run the VFCMT set cluster mode passive for this passive node so that the VFCache will know this is a passive node. We come back to SQL query and create a database and a new table called the test1 and run a query to insert hello world into 40,000 columns. We'll now fail over to the passive node. After failover is completed, we will run an update. This is going to occur on the passive node. And the text is now changed to updated world is here. Now we are going to attempt a failback. After the failback is completed, we will check if there is any dirty read by running the same query. Connect to the database and run the query. Now, the update sets from the passive node are here. To summarize, this EMC solution has shown the implementation of multiple business-critical applications in a VMware private cloud environment hosted by VMAX 40K storage and VFCache. Each application had different workload characteristics and placed varying demands on the underlying storage. VFCache provides better performance for the applications that involve heavy read I/O. With 3-tier FastVP configuration, VFCache significantly offloads array IOPS. The array is then freed up for other I/O requests. With 2-tier FastVP configuration, VFCache reduces disk latencies and response times, enabling higher transaction throughput for the applications. VFCache works seamlessly with SQL Server Failover clustering to ensure source-long acceleration while guaranteeing data integrity during failover process. Thank you for viewing this demo. For more information, please visit our website, community.emc.com/community/connect/everything_Microsoft for white paper and other documents related to this solution.